What's up? Math 6 1.4. Today we're talking about prime factorization. And when I say prime factorization, I do not mean these kinds of primes. These kinds of primes have been making terrible movies lately. So instead of talking about them, let's move on and talk about primes that are actually cool. Alright, so what's a prime number? Well, prime number, or prime numbers, are whole numbers that are greater than 1 and whose only factors are 1 in themselves. Now, what do I mean by that? Well, take the number 5, for example. How can you multiply to get to 5 using whole numbers? Well, 1 times 5. That's it. Right? Yeah. Okay, what about 7? 1 times 7, right? 11? 1 times 11. What about 5 times 2? Nope, that's 10. 13. So those are prime numbers. So those are the types of numbers that we're going to try and get to today. We're going to start with what are called composite numbers, which are non-prime whole numbers, such as 12. And we're going to try and get them down to a series of prime numbers multiplied together. And that'll be what we call our prime factorization. However, first, before we do that, we're going to talk about what are called factor pairs. Okay, why do I say pairs? Well, pairs of shoes. Think about that. There's 2, right? 2 numbers that multiply together to create another number. So let's talk about 20. What are the factor pairs of 20? Okay, so as I want to find the factor pairs of 20, here's what you need to do. Write the number, in this case 20, and then I like to write a colon, all right? And then some people call this the rainbow method. I don't know, you can call it the bow method, whatever you want. And then I say, what's the first factor of 20? I'll give you a little hint. It's the first factor of all numbers. It's 1. Okay, and I'm going to write a 1. But then I ask, well, 1 times what would give me 20? It sounds kind of like a stupid question. And it kind of is in a sense because we all know that 1 times 20 is 20. So I'm going to give myself some space and write the number 20. Okay. Now here's where the rainbow bow method thing comes in. Some people like to do this. Okay. You can do that if you want. You cannot do that. I don't care. So the next, though, I say, well, what's the next factor pair from 20? And I usually start down the lows and work up. So after 1 would be 2. Does 2 go into 20? Yes. So comma, and then write a 2. But 2 goes into 20 how many times? 10. So then I go, next to my 20, I put a 10. And because I know that 2 was the next factor after 1, that although there are a lot of numbers in between 10 and 20, none of them are going to be factors of 20. So I can go ahead and do the bow. Oops, that was a bad bow. That's better. And I don't need to leave any space there, okay? Now what's next? 3? Yeah, but 3 is not a factor of 20. 3 times 7 is 21. It's not 20. So what's next after 3? 4, comma, 4. Well, 4 times what gives me 20? Well, that would be 5. And so I'll write a 5 over here and then connect with the bow. And then I go, hey, what's in between 4 and 5? That's a whole number? Nothing. There's no whole numbers in between 4 and 5. So guess what? I'm done. I just listed the factor pairs, okay? 1 and 20, 2 and 10, 4 and 5. Now, sometimes we write them like this, 1 and 20, and then like maybe like a semicolon, 2 and 10, semicolon, 4 and 5, semicolon, or 4, comma, 5, and then you're done. So you could write it like that, you could write it like that. I'm not terribly picky. If someone said, hey, list 1 factor pair of 20, you could say 2 and 10. But if they said, what are all the factor pairs of 20? You do it one of those 2 ways. All right, so I'm sure you're fine with that. Why don't you pause the video, try this one, play it when you're done. All right, factor pairs of 36. Remember, write at 36. Go ahead and do your rainbows. 1 times 36. All right, I'm not even going to connect them this time because I don't have to. And then 2 times what? 2 times 18 gives me 36. 3, is that a factor? 3 times what? 12. Okay. What's next? 4. Yep. 4 times what? 9. And what you can see is that the numbers that are left are actually getting they're narrowing down. Why? Because originally it was all between 1 and 36. Now it's between 4 and 9. And so if I go to 5 times, no, that didn't work. 6. 6 times what gives me 36? Well, 6 times 6 gives me 36. So I don't like to do this. Some people do. They do 2 6s. I don't like that. Why? Because 6 is its own number. So that's kind of why I don't like to do the rainbow thing, because if you do the bows, you do it there, and then there, and then there, and then there, and then what do you do with 6? Well, you leave them alone. So I don't really care what you do, but you need to acknowledge that 6 times itself is indeed 36. So, if you were listing the pairs, I could see the case to do that. Or, you know, it's fine. You can do another 6, so 6 and 6 like that and do a little swoopy thing. That's fine. I don't really care, as long as you understand that those are the factor pairs. All right, primes that aren't about transformers, because those movies are lame now. Prime factorization. We're going to use a factor tree to find the prime factorization of 24. What do I mean by a factor tree? Let's talk about factor trees. All right, factor trees are really easy. You can start a factor tree in a number of ways. How can I start a factor tree? Think about what we just did. Factor pairs. Okay, so we're looking to do the prime factorization of 24. The way we do that is we use a factor tree. So I got to break down 24 into two different numbers. And those two numbers got to multiply back together to get 24. So I can't use 1 and 2. Why? Because 1 times 2 is 2. It's not 24. So what's a factor pair of 24? How about 6 and 4, right? 4 times 6, 6 times 4. That gets you 24. So I'm going to do a 4 there and a 6 there. Now, are either of those prime numbers? No. Why? Because 1 times 4 is indeed 4. But guess what? So is 2 times 2. So 4 is not prime. What about 6? 1 times 6? Yeah, but 3 times 2 is also 6. So that doesn't work. So neither of them are prime. So what does that mean? It means you need to keep breaking down. So I can break 4 down into what? 2 times 2. 2 and 2 are factor pairs of 4. All right, now look at 6. How can you break down 6? Well, there's really only one way to break it down other than using 1, and we don't want to use 1 here because it doesn't really help us, because if we did 1 and 6, guess what? I'd have to break 6 down again anyway. So how about 2 and 3? Okay, now guess what? All those numbers I just wrote are all prime. 2 is a prime number. Why? Because the only way to get to 2 is 1 times 2. 1 and itself. Okay, so that's prime, so I'm circle it, circle it, circle it. 3 is also prime, circle it. So guess what? We're done, right? Wrong, we're not done. You use a factor tree, use it to find the prime factorization. Prime factorization is really easy. All you got to do is this. 2 times 2 times 2 times 3. Now, the one other thing we're going to do, though, is we're going to take that and we're going to rewrite that using what we know about exponents. How many times is the number 2 being multiplied there? 3 times. So what's my base going to be? 2. What's my exponent going to be? 3. And then I can't forget about that other times 3. That right there in the box is the prime factorization of 24. 2 to the third times 3. All right, you're smart. You can figure that one out. Go ahead and pause the video. Try it. Play it when you're done. All right, hopefully your factor tree got you to the following prime factorization. No. Prime factorization. Yeah, here we go. There you go, just like that. Now, you might be looking at that and saying, I got the same thing here, but I did not do 5 and 8. I took 40 and I did this, 4 and 10. Well, guess what? That's totally fine. Why? Because you break them down. 2 and 2, prime, prime. 2 and 5, prime, prime. Guess what? 2 times 2 times 2 times 5. Do it my way. 2 times 2 times 2 times 5. Do it anyway. 2 times 2 times 2 times 5. It doesn't matter how you start. The beautiful thing about prime numbers is you're going to get back to the same thing as your neighbor or me or whoever else anyway, and we should all end up with that answer. Easy as that. Last one, food for thought. What does the following prime factorization represent? What number is actually represented by that? Well, how do we do that? Well, it's easy. Just go backwards, right? So, order of operations here says I would need to take care of exponents before I multiply. So that's really 2 times, well, it's 3 squared. 3 times 3, which is 9, times 5. What's 2 times 9? 18. Times your 5. And what is 18 times 5? Line it up. 18, 5, multiply. 5 and 8 is 40. Carry the 4. 5 times 1 is 5. Plus 4 is 9. 98. 2 times 3 squared times 5 is representing the number 90. That's all I got for you guys. I will see you in class.